Hello, 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 everybody, and welcome back. I hope you're all doing well. We're going to be finishing off our 2017 Grade 7 Gauss paper in this video by looking at question number 25. And if you haven't taken a look at question 25, I would encourage you to do so before venturing further into the video. Done? Good. Okay, so let's take a look. What have we got for question 25, the last question on the paper? Ashley writes out the first 2017 positive integers. She then underlines any of these integers that is a multiple of 2, then underlines any of them that is a multiple of 3, and then underlines any of them that is a multiple of 5. That's it, okay. Finally, Ashley finds the sum of all the integers which have not been underlined. What is this sum? Okay, so we've got some pretty big numbers on offer with our 5 possibilities, and I suspect we'll probably need to do some clever calculations. I've got my calculator handy, but the first thing, as always, is we have to think of a way to approach the problem. We have to think of a line of attack or an insight or something to try out. Now, 2017 is a pretty big number. It's the current year. They usually throw it in just because it's big, it's unwieldy, and it's sort of meant to scare people off. But there's nothing special, really, about 2017. Right? We're talking about multiples of 2, multiples of 3, multiples of 5. So we could say, well, what if I just looked and did this process for the first, say, 17 numbers? And that's much more manageable, and we might find some patterns there. Okay? So when in doubt, when you take a look and say, well, that's really big, that's a really long thing to write out, or something like that, try and break it down into a smaller pattern, a smaller quantity, a smaller list, and see, it takes some time, it takes some finesse. It's sort of a learned art to how to say, well, they asked for 2017, but looking at maybe just 17 will be good enough, or looking at 27 will be good enough. So, you want to look at a smaller number, sure, but you still want to retain the essence of the problem. Like they're talking about the first 2017 positive integers. If we did this with, say, the first 4 positive integers, yeah, we could do it. 2 and 3 will be underlined, 1 and 5 aren't, 1 and 4 aren't, and they add up to 5, but, we haven't really retained a lot of the difficulty or the nuance there because we don't have any multiples of 5, and there's no overlap. There isn't a multiple of 2 that's also a multiple of 3, and so we want a big enough number that we have this nice interplay of 2 and 3 and 5, but still small enough for us to manage. Okay? So something that might come to mind would be, well, 2 times 3 times 5 is 30. So we might take a look at the first 30, something like that. So that's a possibility. Another plan I'm having, instead of just looking at something small, would be to say, okay, how are we going to add this up? Okay, so we could do sort of one of two things, I think. We could add up all the numbers from 1 to 2017, and then take away all the numbers that are underlined. Now that's going to be tricky, because you can't just take away all the even numbers, then take away all the multiples of 3, and then take away all the multiples of 5, because, and I mentioned this just a moment ago, there are some numbers that are multiples of 2 and 3, or 3 and 5, or 2, 3, and 5, your multiples of 30. So we don't want to be counting those numbers more than once. When I take away 6 as part of my multiples of 2, I don't want to then take away 6 again as a multiple of 3, if you see what I mean. So that's a possibility. So we could add them all up and then subtract away the numbers that we don't want, the ones that Ashley has underlined. Another possibility is we could just find out a way to add up all the numbers that Ashley underlines. I'm going to investigate this one first, and then I might do the other method. And I actually don't know which one's going to go faster. But if I think about, say, the first 30 numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 30, 29, 28, 27, 26, 25, 24, 23, 22, 21, and let's clean up that 25 there. There we go. Okay, multiples of 2, where are we? So we would underline these ones. I'm just using red for the multiples of 2. I guess we'll use maybe blue for the multiples of 3. But we'll underline those and see which numbers we actually include, which ones we don't include. We're starting to run out of numbers, and now multiples of 5. Okay, we didn't really get rid of that many this time, but what are the numbers that are left? And we'll highlight them, I guess, in orange. So there's 1, there's 7, there's 11, there's 13, there's 23, there's 17, there's 19, and there's 29. And you might notice these are all prime numbers, except for 1, which isn't a prime number. And that's very much just sort of a coincidence. Would be 30, no, not 35. 77 will eventually be on this list, but he's not a prime. Okay, but these numbers, all right, we could add these up, and that would be a nice small case. But think about what's going to happen for the next 30 numbers. So 30 is kind of special here in that things sort of reset. 30 is a multiple of 2, which means 2 numbers later, you're going to have another multiple of 2. And 3 numbers later, you're going to have a multiple of 3. And 5 numbers later, you're going to have a multiple of 5. And I guess we can add in 34 here. So that's a multiple of 2. And so look at the pattern that we're getting. Up top we go, number we need to add up, number that isn't underlined, multiple of 2, 3, 2, 5. Number that we need to add, 2, 3, oops, that should be blue, shouldn't it? I picked the wrong color. It was going too fast. Red, blue, red, green. The next one will be 36. But it's both a multiple of 2 and a multiple of 3. Okay? And so if we write enough out like this, we realize, oh, every 30, the pattern's going to repeat. This next number, 37, is not a multiple of 2, 3, or 5. It's something I have to add up. And so the next one I have to add up after that will be in that spot, and then we'll have this one, and the pattern will just repeat. So what's the difference between the numbers on the bottom half of the screen and the ones on the top? Well, we just add 30. We just keep adding 30. So what are the numbers that Ashley would start adding up? Well, she would add 1, and 7, and 11, and 13, and 19, and 23, and 29. I think that was it. Okay, so those are the numbers Ashley would add up. But then she would add, oops. And then she would add 31, and 37, and 41, which is 11 plus 30. And then she'd add 43, and 49, and 53, and 59. Okay? But this is just the same set of numbers with an extra 30. 7 there. How many 30s? Well, 1, 2, 3, 4, 5, 6, 7. So if I call this first set of numbers S for sum, then 1, 2, 3, 4, 5, 6, 7, this is just going to be S plus 7 30s. What about the next set? The next set of 30 will go 61, 67, 71, 73, 79, and why isn't 77 on my list? I predicted a 77. Did I? Oh, I forgot 17, didn't I? Yeah, I didn't add 17. Okay. Gave myself a little bit of a panic. 77 should be on the list. So, I've missed a number when I was writing these out. That's okay. Obviously not something I want to do when I'm going to write down the final answer, but I'm glad I caught that. So we actually have another one in here, 47 and then 49. We'll have 77 and 79 and then 83 and 89. And so it's not 730s, it's 830s. But this will be the sum of this set of numbers is going to be S, and now we've added 60 each time, so we'll have 8 60s. And then the next set of 30, how many numbers are we going to add? 8 of them, and they're going to add up to S plus 8 times 90. Okay? So we start to notice this pattern. When we do this sum, the sum doesn't repeat every 30, but the number of numbers that we're going to add up repeats every 30, and they differ from the previous set of 8 numbers that we add up by exactly 30, and this makes the sum a lot easier to work out. Okay, so let's finish this off and get ourselves an answer. Now we're going to go up to a certain amount. We're going to go up to, well, 2017's our cutoff, but that's not a multiple of 30. So what's the closest multiple of 30 to 2017? 67 times 30, it looks like on my calculator. I divide by 30, I chop off the remainder. So we'll have a bunch of numbers, and then it'll be 2010. And if the pattern has been followed, the one before it, and the one that's 7 before it, it's going to be the same set of numbers here. And then 2010 is going to be our multiple of 30. So it's a multiple of 2, 3, and 5. And then what we have, we'd have 2011, and that would be something to add. 2012, no. 2013, no. 14, no. 15, no. But the one that's in the 7 spot, the 2017, is. And so we'll follow this pattern, and then we also have to remember to add on 2011 plus 2017. Okay. So now we're starting to get somewhere. So Ashley's sum is what? Well, it's actually, I should probably figure out what this S value is. I'll just grab my calculator. 1 plus 7 plus 11 plus 13 plus 17 plus 19 plus 23 plus 29. 210. It's not 210. Ugh. I'm having a bad brain day. 120. I got the two numbers at the start flipped around. 120. Okay. So then the sum of the next 30 that we would want, the sum of the numbers in the next set of 30 integers that we would want to add up is going to be 120 plus 8 times 30. So that would be 360. And then we'd add on another 830, and so we would get plus another 240, so that would be 600. And then we would get another one, so that would be 840. So the numbers that we're adding up are going to be 120 plus 360 plus 600 plus 840 plus, and it'll just keep going until the sum of the ones for the 30 before 2010, and then plus 2011 plus 2017. So how can I find these numbers? Where are they coming from? Well, this is 1 times 120. This is 3 times 120. This is 5 times 120. 7 times 120. 9 times 120, and so on. So the first 30 gave me a sum of 120. The second 30 gave me a sum of 3 times 120. The third gave me a sum of 5 times 120. Okay. Well, what set of 30 is this? This is the 67th set of 30. And how am I going from first, second, third to 1 times 120, 3 times 120, 5 times 120? I'm doubling the number and subtracting 1. So this should be 2 times 67 minus 1 times 120. Okay? So we're really starting to understand what's going on here. So we've got 120 times 1 plus 3 plus 5 plus 7 plus all the way up to 2 times 67 minus 1, 133. And then we have to remember, add on 2011 and 2017. So 120 times a big sum of odd numbers. Now, if you haven't seen this before, I don't mean the whole question, I mean specifically adding up 1 plus 3 plus 5 plus 7, you're in for a bit of a treat. 1, it's obviously 1. 1 plus 3 is 4. 1 plus 3 plus 5 is 9. 1 plus 3 plus 5 plus 7 is 16. 1, 4, 9, 16, 25, 36. These numbers should be ringing a bell. They're squares. Okay? So, how can we figure out, if we add up from 1 to 133, what square is that? What perfect square should that be? Well, we had our numbers 1, 2, 3. So the third set of 30 numbers gave me 5 times 120. Well, it turns out that 1 plus 3 plus 5 adds up to 3 squared, 9. Adds up to 4 squared. So since this was the 67th one, Ashley's sum is actually 120 times 67 squared plus 2011 plus 2017. Now let's punch that in on a calculator. And 2011, the 2017. I'm getting an answer of 542708. And I think that actually is, unfortunately, a little too big for the numbers that they had presented. Oh, no. I thought they started 5.3. They start 5.4. Looks like our answer is A. So if we're confident in the work and the pattern that we recognized, great. We get ourselves an answer of A. And as I say, that was one method that I thought. I like it because we actually reduce it down, look at a little pattern, first 30 numbers, and we realize 30 is kind of special because it's 2 times 3 times 5. The pattern's going to keep repeating. Okay? But maybe you found that a little difficult. Maybe you don't like trying to directly compute. Maybe you're better at picking out numbers than you are at just adding up the numbers that we actually want. So let's try and do the question a different way. I don't normally do this, but I'm actually curious as to see which method's going to be faster or easier for me. So I invite you to come along. If you're satisfied with the answer of A that we got there, great. Thanks for watching. Like, subscribe, blah, 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 blah. But, if you want to stick around and try and do it a different way with me, let's try it a different way. Okay. So what could we instead do? Well, we could instead add up all the numbers that Ashley wrote down, and then subtract all the multiples of 2, subtract all the multiples of 3, and subtract all the multiples of 5. But those are, of course, the numbers that Ashley underlined. And as I've already remarked, there's a problem here. Some numbers are multiples of 2 and 3. And so they would appear on both lists. Think of the numbers that we would subtract: 2, 4, 6, 8, 10, and so on. What are the numbers we'd subtract that are multiples of 3? 3, 6, 9, 12, 15, and so on. How about the multiples of 5? 5, 10, 15, 20, and so on. But we've got numbers that are appearing in both lists. And in fact, 30 will appear in all 3 lists. Okay? So we don't want to subtract 6 away from our total twice. We can't do that, because then we're not actually looking at the numbers that Ashley has not underlined. We're removing 6 too many times. So the way to get around that is to add in the multiples of 6. Because that way, what am I going to be adding in? 6, 12, there'd be another 12 in here. 6, 12, 18. So now, when I subtract this 6 and this 6, I add back in another 6, and sort of 2 of these cancel each other out, and we're really only removing 1 6. We're really only going to be removing 1 12, because we take away 2 12s, but we add another 12 back in. And so the same thing goes, we have other problems. You know, there's numbers that appear on the 3 and 5 list. Oops, 3 and 5 list there. 15's on there. 10 is on the 2 and the 5 list. So to get around this, we also have to add in the multiples of 10 and the multiples of 15. Because any number that's a multiple of 3 and 5 is also a multiple of 15. Great. So this is what's known as the principle of inclusion and exclusion. We recognize that we're counting the same thing twice, or we're taking the same thing away multiple times. So we cancel it out by looking at a smaller, more precise subset of things. Now, you might think we're done. 30 is going to be on this list, 30 is going to be on this list, 30 is going to be on this list too. And so we subtract 130, we add 130. So no change. We subtract a 30, we add a 30, no change. We subtract a 30, we add a 30, no change. We still need to subtract a 30 from this original list. Our net change is no 30s, no 60s have gone away. But that's definitely an underlined number, so we actually have to subtract the multiples of 30 as well, and then we're finally done. And of course, there'd be more steps if we were also dealing with, say, the multiples of 7, if Ashley had decided to underline those as well. It would be a longer inclusion and exclusion, but we're fine as it is. This is going to be enough. So, how can we start adding up these numbers? Well, there's an important formula, and you might have seen it, especially if you tried to do the question this way. N times n plus 1 over 2 is the sum of the numbers 1, 2, 3, all the way up to n. I'm not going to sit here and prove this formula, because I think the video is going to be long enough as it is with me doing the question 2 ways. But it is a very nice formula, and it's one that I do highly recommend you know, especially if you want to keep doing more math contests. So what does that tell us? Well, 1 plus 2 plus 3 all the way up to 2017 is going to be 2017 times 2017 plus 1, which is 2018, divided by 2. And then what do we need to do? We need to subtract the multiples of 2. Well, that looks like 2 plus 4 plus 6 plus all the way up to 2016. Well, that doesn't exactly look like my formula here, and you're right, but we could instead factor out a 2. And 2016 divided by 2 is 1008. So this sum is going to be 2 times 1008 times 1009 divided by 2. And so we'll take that away. And then we also need to take the multiples of 3 away, which, when we get down to it, looks like this. What's the nearest multiple of 3 to 2017? It's also 2016. And when we divide 2016 by 3, we get 672. So the sum of those numbers is 3, so we still have this 3 out here, times 672, 673, all over 2. And how about the multiples of 5 that we take away? Well, what's the nearest multiple of 5? It's 2015. 2015 divided by 5 is 403. So we get 1 plus 2 plus all the way up to 403. And the sum of that would be 5. 403 times 404 all over 2. And then what about the numbers that we add back in? Well, the multiples of 6 and the multiples of 10 and the multiples of 15. And what's the nearest multiple of 6 to 2017? Well, that's also going to be 2016. So 2016 divided by 6 is 336. How about the nearest multiple of 10? Well, that one's not bad at all. It's 2010, so divide that by 10. Divide that by 10, 2010. How about 15? The nearest multiple of 15 is, I suspect it would be 2015, but no, that's not right. Oh no, it's going to have to be 2010 because that's also a multiple of 30. So we divide 2010 by 15. So what this is saying is between 15 and 2010, there are 134 multiples of 15. finish these sums off, and then we're going to have to deal with the multiples of 30. But I think you're hopefully seeing the pattern by now. Well, not necessarily a pattern, but just the general technique. We would want to add up the numbers 30, 60, 90, all the way up to 2010. And that's going to be 2010 divided by 30. We just had it a second ago. 67, yeah. We used it in the earlier part of the question. So what's the sum of those numbers? 30 times 67 times 68 all over 2. Great. Now we just need to calculate. So we take this number, subtract off these 4 values, add in the, sorry, I said 4, those 3 values, add in these 3 values, and then subtract this value off again. Okay? So we probably want to do this in chunks. 2017 times 2018 divided by 2 is 2035153. The reason we want to sort of do it in chunks is so that we don't make too big of an error or screw something up when we're pressing buttons. So 1008 times 1009 divide by 2 multiply by 2 is going to cancel out. How about 3? So that was, what was that? 2016 divided by 3. So 672 times 673 divide by 2 multiply by 3. 678,384. How about the 5s? 403 times 404 divide by 2 multiply by 5, because each of them is a multiple of 5. 407030. All right, now what do we add in? So that was the previous page. So 336 times 337 divide by 2 multiply by 6. So now we add in 339696. How about the 10s? 2001 times 2002 divide by 2 multiply by 10. So we're adding in 203,010 and the multiples of 15. 134 times 135 divide by 2 multiply by 15. 135,675, and then the multiples of 30. So 67 times 68 divide by 2 multiply by 30, and we subtract those. Okay, I suppose I should have switched back to black a while ago, but now we just subtract or add up all these numbers as we need to. Times like this, I wish I could talk and also use my calculator. 339696. Probably a good idea to stop every once in a while and double check that you're actually punching in the right numbers. Because you don't want a single finger slip, especially if we haven't done the other technique. 68340. But at long last, I did finally get the same number as the first time, and I think that was an answer of A. Yeah, an answer of A. All right, so fantastic. So there's 2 methods there. I think the second one was a little faster, but that's because I knew the formula n times n plus 1 over 2. So I wasn't so much recognizing the pattern of the numbers that we want to actually add up, more as being very skilled with inclusion, exclusion, and my formula n times n plus 1 over 2. I also knew things like that 67 because I did the first technique. I definitely think it was the faster one, but I like that there were actually 2 wholly different ways to do the question. Pattern recognition involving 30, and then a sum, or trying to do this inclusion, exclusion technique. If you have another way to do it, I would love to hear about it. And if you actually tried this question, I would love to know, did you do it the first way, the second way, or a third way that I would love detailed. But yeah, I really like that question. I really like it when there's 2 different ways, 2 distinct ways to do a question. And it worked out that we got the same answer both times, so that's even better. Okay, that finishes off our 2017 Grade 7 Gauss. Of course, if you're looking for a bit more of a challenge, you can start looking at Grade 8 Gausses. I have many other grade 7 Gausses around my channel as well, so you can take a look at those. And that's really all for me. Thank you guys so much for watching, and I will see you for more math in future videos. Take care.